I'm not going to go into very deep about how we do these models, but I certainly want to give our modeling strategy. Given the forum that we are in, we all have either used models or are using models or are in the process of evaluating whether we should use models or not. So having a good modeling strategy is very, very important. The way I try to put this up here is similar to what Fluent or ANSYS does. It's a pre-processing, there's a solver, and then the post-processing. Pre-processing is what really makes whether or not what you're solving accurate, whether what you're not solving is correct. In the business scenario, it is identifying why you're using a model, what are the results, how will you be using these results, what physics will need to be modeled, are they available, how much trust do you have on those physics, and then choose the right modeling methods. That just because you have CFD software doesn't mean that everything should be done by CFD. Sometimes based on the scenario and based on what you're being asked, based on the question for why, you can actually use simpler models, use Excel models, but you have to be able to identify why you're doing it, what needs to be done, and how you will do it. Then comes the development of the model itself. This is where getting accurate info is very, very, very important. In our case, we typically model processes and equipment, so process knowledge and equipment knowledge is extremely important. We've all heard this garbage in, garbage out. This is where you can put garbage in and then you will have garbage out, and that most important part of that kind of a scenario is that people lose trust over a model like that. And once you lose trust of people that are looking at you for an information that can help them, and you give them not good information, that takes a really long time for you to get back that trust. So this is just as important as identifying what you're trying to do. We build a model, we verify the model. This is, again, very, very important. You verify, you verify, you verify. Once you have the verification, that is where you know whether or not this model is useful in what context. This is what we call a context of use. You absolutely have to be extremely careful in understanding what the context of use is. A very, very good model can be used in the wrong context and be very dangerous. Then we use it and we deploy it. And when you're deploying the model, you basically are very careful in making sure that the people who are using the model, understand the context of use, and know how to actually see the results and use them in a business-centric way. Then we document the model and document the uses and limitations of it, and we improve as the model it requires it to be. Sometimes we have models based on the first 3 questions. We have models that are very, very directional oriented. We are not too worried about the exact numbers that we are getting, and we don't need it to be too accurate. We want to know whether or not this will even work or not. And in those cases, our context of use is very directional use. But once we have that model and we have a certain piece of equipment or a certain piece of process in place, now we want to be a little more robust and a little more add a little more value to the model, and we are saying, can we operate at this parameter? What does it look like at this RPM or this pressure, whatever it is? And at that point, we decide that we need to improve the model and go through this whole process again. So anyone who's using the models or anyone who's trying to use the model, having a good modeling strategy is always very, very important. This is what we use, and this is what I have developed over the past decade of experience. This doesn't need to be exactly like this, but the elements of these should be always a part of your strategy.